Okay, we're back. I probably need to get through this. I'm going kind of. So you saw the how hot air balloons work, and then the next thing, use hot air because hot air is less dense. Okay, instead of hot air, we can fill a balloon with helium. There's mostly of hydrogen. The low density of the helium compared to the Earth's atmosphere allows the balloons to float. Okay, but the hot air is easier to control because you can cool it and come down. Helium, you got to start popping balloons. Balloon first was the first balloon to fly nonstop around the world. They're 28,431 miles, lasted 19 days and 21 hours. The Breitling Orbiter 3, Breitling is, of course, a very, very fancy watch, took off from the Swiss Alps and ended in the Egyptian desert. Steve Fossett became the first person to solo pilot a balloon around the globe. Did it in 2002. Lead balloon. This video doesn't work, but you can watch the Mythbusters trying to build an 11-kilogram lead balloon. Now, it will work. A lead balloon will work if you fill it, if it is thin, if it has enough volume, and the 11-kilogram mass is small enough. In other words, you've got to make it less dense than air. And so what does the volume of that thing have to be? And so that's kind of a fun calculation. Let's go ahead and look at that calculation really fast. All right. And this will drive the point home. I think this might be one of my, according to you all, might be one of my worst lessons, but I think it's one of my best because we're actually I feel like I'm in class. It's kind of fun. So a lead balloon. All right. I've got a mass of 11 kilograms of lead. Okay, a mass of 11 kilograms of lead. I don't know what the density of lead, but lead is very, very heavy. Okay, shoot. I've started off on something now I don't know because I kind of need to know the density of lead. All right, so I've got to make this 11-gram mass. In other words, I've got to make it lighter than air. Okay, so I've got to take this 11 kilograms times some volume has got to be less dense or has got to be lighter than, oh, I'm going off on a wild tangent here. I apologize for that. We'll stop here. We'll get out of this for. I'm always doing that. I get myself in trouble. Okay, didn't mean to. All right, so let's go back to this lead balloon thing. But what you have to do is you got to make the helium volume, the 11 kilograms times the volume of helium, and get the mass of helium less than the air that it displaces. The volume times the mass of air. Okay, so we'd have to find the density of and fill it with helium. Had to find the density of lead and then make it less than helium. I'm sorry, I kind of got off. That's one thing. You should never wing things. This is crazy. This cluster ballooning. You've got a little video on that. All right. I think we already answered that one. Hot air balloon, balloon first. Wow. Oh, here we go. Here we go. Here's the classic of all time, the Zeppelins. The problem with the Zeppelins, they were filled with frickin' hydrogen. One of the most explosive things in the world. So, that causes issues. That causes issues. So here you go. There's a classic.
The ill-fated Hindenburg on her last flight sails over New York. The airship was hailed by thousands who little dreamed it was their final glimpse of the Hindenburg. Again she dumps ballast, and a nervous tension grips those who are watching, for this is something unusual.
The back motors of the ship are just holding it just enough to keep it from... It bursts in the flames. Get it started. It's fighting, and it's crashing. It's crashing terrible. Oh, my, get out of the way, please. It's burning and bursting into flames, and it's falling on the mooring fast, and all the folks between it. This is terrible. This is one of the worst catastrophes in the world. Oh, it's like 20, 400 or 500 feet into the sky, and it's a terrific crash, ladies and gentlemen. The smoke and its flames now, and the frame is crashing to the ground, not quite to the mooring mast. All the humanity and all the passengers screaming around it. I told you, I can't talk to people. There's friends around there. I can't talk, ladies and gentlemen. Honest, it's just laying down massive smoking wreckage. And everybody can't...
Okay, so that guy's obviously upset, and you know, and I don't mean to make light, and it is upsetting. Why did the Hindenburg burn and all that? There are some very, very interesting theories behind it. They of course they came up with a pretty good one, and basically what they kind of found out was in this part right here, you got what is known as a St. Elmo's fire, which are chemical, which the hydrogen was kind of leaking out and was causing, and due to the skin of the Hindenburg, that they used, it was causing this vapor to take place. And so when they dropped those lines, the things were starting to run to ground, and when the mooring things attached, a spark, just one little spark of static electricity, went flying up one of those mooring rounds, hit that St. Elmo's fire going at the top, and boom, burned. If you want to find why the Hindenburg, the Unmuseum, it's pretty good. It's a pretty good little video on what happened. All right. So where are we? Here we are. 35 of the night, 62 people got out alive somehow. Okay, now we're going to talk about buoyant force, why things float. If something is you guys already figured this out with the baseball thing. We're going to do the buoyancy, but we're going to do a buoyancy force. We're going to use a big old beach ball, okay? I meant to ask this question. Okay, imagine holding two identical bricks underwater. Brick A is just beneath the surface while brick B is at a greater depth. The force needed to hold brick B is the same due to the forces are the same going around it. Okay. The density of the fluid around it is the same, so it stays the same. Yep, there we go. Buoyancy force, scuba, you've got to get underwater in scuba. All right, the human body has a volume of 0.08 meters cubed, therefore displaces that amount of water. See, this is what I needed. I needed to know remember that we learned from balloons, volume of displaced air times the density of air times is the buoyancy force to keep it up. Okay, and so the volume of, here's what I needed for my lead balloon. Okay, but we were also going to use, if I made the volume big enough, it would be less dense. But if I also put helium in there, it should work. Anyway, sorry. Okay, so you can float in the Dead Sea, you can do all that stuff. Buoyancy of a basketball, buoyancy in space, all right? Buoyancy in space. Is there a buoyant force in zero gravities? No, there is not. In fact, this is what a candle looks like burning on the space station with zero gravity. Because this is different chemicals that have different weights, different densities, and so they float to the top. And at the very top is the carbon escaping, the black carbon escaping. This one, Gravity's the same, so you just get this blue ball. It's really kind of cool. All right. Friction. Now we'll talk about this. Static friction is what helps you move forward. Kinetic friction is when you're sliding. All right. Static friction, when you're running, pushing off this way, going that way. You push the earth this way, the earth goes, hey, get going that way. Static friction surfing. This is why you wax your boards so that your feet will stick to the board, so when you're like this, you don't go sliding off. Waxing the boards has nothing at all to do with making the water more slick. It actually makes it more sticky when you wax the boards. And so your feet stick. Sumo wrestlers, tremendous amount of friction here and trying to get each other to move. Then we'll talk about drag in the next video.